Good day. Today in this session we'll talk about queues and its applications. Before we see the implementation of queues, let's talk about few of its advantages where this queue is used in real time. A queue can be used in all the situations wherein events has to be processed in the order in which they have arrived, and we know the definition of queue. Okay, let's talk about queue as a data structure. Okay, when we talk queue as a data structure, then queue should also has four things associated with it. First, it should have its definition. Second, how it can be implemented, and what are the different types of operations which are supported, and what are the attributes which are associated. Okay, operations, O-P-E-R-A-T-I-O-N-S. Okay, so as far as definition of queue is concerned, we know that queue is a first in, first out data structure. We imagine that we have a pipe, and this pipe is opened at two ends. Okay, it is like this. When I put a coin from this end, okay, then the coin goes from that end. Okay, it is removed from that end. So if I have just sent coin number 1, then coin number 2, then coin number 3. Okay. Now from another end, this coin, which coin will come first? Will 2 come first or 3 come first? No. The order in which the coins have been inserted into the pipe, in the same order, the coins will be removed from the pipe. Okay. Meaning, first sent coin was 1, then it was 2, then it was 3. Then the first coin to be removed from the queue will be 1, then will be 2, then will be 3. So that's why it is called first in, first out data structure, or last in, last out data structure. Now, queue can also be implemented with the help of arrays, and it can also be implemented with the help of linked list. Now, what are the different operations which are allowed on queue? On queue, we can perform enqueue operation, or we can also call it as add. Okay, add an element. Add. What this add function or enqueue operation does is, it adds an item to a queue. Second is dequeue. Okay, or remove. Call it as remove. Remove is nothing but removing an element from a queue. So while adding an element, we have to insert an element. While removing an element, removing an element means removing an element from the queue. So it will be removed in, first out order. Now, in order to see the contents of this queue, we'll call a method called display. Okay. This will tell us this will actually help us in seeing the elements of queue. Now, implementing queue with the help of arrays, takes a lot of work factor, which will do analysis while discussing algorithms. Because on array you have to do a lot of operations for inserting an element, okay, removing an element in between, or from any position, given position. But the good part of queue is, here insertion can be done from one end and deletion can be done from another end. For example, we have already studied stack. Okay. In stack, insertion and deletions, okay, can be done from same end, but whereas in queue, insertion will be done at one end and deletions can be done at another end. So both operations, insertion and deletions, are possible, but at different ends in a queue. Now, what are the attributes which are associated with this queue is, there are two attributes. Like in stack, we have a top pointer. In queue, we have front and rear pointers actually. So they will keep. Now, how this queue works? How to design this data structure? It is like this. Assume that I have an array of size, for example, 2, 3, 4, 5, 6, 7, 8. Okay. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are maximum size of this is 10. There are 10 elements ranging from 0 to 9. Now, whenever I want to do any addition to a queue, what do I do is, suppose I want these elements to be inserted. What are those elements? 5, 10, 15, 20, 25, 30. These are the elements I want to insert. Now, I will maintain two pointers or two variables here called front and rear. front and rear. Initially they point to -1 here, because it means they are not pointing to anywhere. Like for top, we did top is equal to -1, or initially we can say that front and rear are pointing to same element, element 0th. This is the initial condition. Okay, so it's your wish that how do you visualize it. Now, when an element is added, suppose the element added is, for example, 5. Okay. So when I add an element 5, what happens? 5 will be added at what end? Initially, we cannot distinguish whether it is front or rear. Okay. Now, always remember, front points to the first element that has been inserted into the queue, and rear will always point to the last element which has been inserted. Okay. Or next cell is free, for example. So when front, when one element is added, okay, what happens? Front is pointing to 0, and rear will point to the next element. Rear will be forwarded by one location. Then next, what happens? Another element will be added, which is 10. When this element gets added, then rear points to next element. Okay. Then again, when new element comes, then it will be 15th element will be stored at this location where rear is pointing to, which is 15. Let's call this array by name Q, for example, Q-U-E-U-E. This is the name of this array. So then R points to third location. Then when another element is added, 20, okay, then R points to 4. Then 25 is inserted, and R points to this. Then 30 is inserted, then R points to 6. Now, so on, this goes on. It means whenever we do addition, or whenever we want to add an element to a queue, then addition is performed at the rear end. Okay, and deletion, suppose if I want to remove an element. Now, what is the first element that has been inserted in the queue? 5, then 10, 15, 20, 25, 30, right? So first element that will be deleted according to the definition is 5. So 5 will be deleted first. When 5 gets deleted, then front points to the next first element that has been inserted. Okay. Then again, if this 10 is also deleted from a queue, okay, then again F points to next element. Again, if I delete it, F points to this element. If I delete one more, F points to 25. If I delete this 25 as well, F point to 30. Okay. If I delete 30, then F point to 6. So it means when R and F both are equal, okay, it means Q is empty. Now this situation where R and F which are empty, yes, of course Q is empty, and also when front and rear were initially pointing to 0, 0, R is empty, Q is empty. So this is one of the cases where we can find whether a queue is empty or not, and we need this situation while implementing this queue. So this is how queue works. Additions will be performed at the rear end, and deletions will be performed at the front end. And that's what, 2 operations are allowed at 2 different sites of a queue. Now let us see how to implement this data structure. Now, what are the difficulties do we face when I want to add an element? Okay, now I am calling NQ for adding an element, ENQUEUE, NQ for adding an element, and second is DQ for deleting an element. Okay, so let's call one more called display method, which I would like to have on this data structure, which gives me all the elements which are available. Okay, now I have a queue. And suppose the size of this queue is 5. 1, 2, 3, 4, 5. Okay. We have 5. 5 means It ranges, index ranges from 0 to 4. Now, can I add an element? When this is case A, initial situation where Q is empty. Okay, where Q is empty, in this case A, is NQ is allowed? Yes, NQ is allowed. Is DQ is allowed? DQ is nothing but removing an element. This is not allowed. Is display allowed? Display is also not allowed. Now similarly, we'll see different cases which are possible on a queue, which help us in writing code for queue. Now case B. We have taken, it is empty. What is empty? Q is empty. Let's take a case where Q is full. Okay. Now I have only 5 elements. 1, 2, 3, 4, 5. 0, 1, 2, 3, 4. Then 5, 10, 15, 20, 25. So front points to here, and when Q is empty, rear points to actually 5, because it always points to next available element. So it means it has reached the maximum size, which is 5. Now, is NQ allowed? NQ, adding an element, is not allowed. Is DQ allowed? Yeah, DQ is allowed. Is display allowed? Yeah, display is also allowed, because I have element and I can display it. Now, there is one more situation wherein the category falls into this, which is actually a combination of both. This could be, okay. In case B, we have a normal and special case. Okay, I call. There is no defined terminology like this. We are just naming it for our